Hello, welcome back, everybody. This is chapter 1.6. We are solving linear inequalities. So the goal of this overall lesson here is that you're going to apply your knowledge of solving equations to solving an inequality. And really the only difference between an equation and an inequality is the symbol we use to show the relationship between the two sides. So anytime you have an equation, should have used something other than 7 here. Anytime you have an equation, it's an equal sign, right? Equation. Anytime you use any of these symbols, it's an inequality. And so we're going to do 3 things here with this. We're going to graph simple and compound inequalities. We're going to graph them. Then we're going to do some solving of inequalities, like this problem right here. And then at the very end, we are going to know the difference between and or statements and also be able to solve them. So let's do some of our graphing here. So here's an inequality. This is the less than symbol. This is the greater than or equal to symbol. Down here, these are less than or equal to. Remember, the only difference with the equal to's is it says include me. So let's go ahead and graph these. We're going to graph them on a number line. So I'm drawing a little number line here. And this says that x is less than 2. So our graph should represent all of the numbers that are less than 2. So we're going to start here, right? So 2 is this. And all of the numbers that are less than 2 are the ones to the left. So the first thing I'm going to do is draw an open circle. Now we do an open circle because this says do not include 2. 2 is not a number. So it's open on 2 because it's not a number that makes a true statement over here. Now, the numbers that if we were to plug this in make a true statement are going to be all the ones smaller to the left. So we're going to draw an arrow over there. And so here is the graph of this inequality. Again, 2 is not included, but everything smaller than 2 makes a solution. Whereas on this one over here, this says x is greater than or equal to -1. Well, -1 is included in this because of the equal to, so it's a closed circle. And then this says that x is a number larger than -1, which means I'm going to draw an arrow to the right because those are the numbers that are larger than -1. Coming down here, this down here is a compound inequality. And notice that it has 2 inequality signs here. It's giving us 2 different conditions that have to be met. And those conditions are that x is larger than -1, but smaller than 2. So we want to mark on our graph all of the numbers that are larger than -1, but smaller than 2. So again, these are not equal to's, so they're open circles at -1 and 2. And then we're going to draw a line larger than -1, but smaller than 2. So we don't keep drawing this line this direction because those are all bigger than 2. The only numbers that fit are the ones that are smaller than 2 and bigger than -1. So it's a line connecting them in between. So a compound inequality like this will always have 2 of these lines connecting. Now this is an or statement. This is also another form of a compound, but we're not combining them. This, by the way, over here is an and statement, right? -1 is less than x and x is less than 2. This is an or statement, which is different. Notice that this says we're looking for less than x, less than or equal to, and over here it's x is greater than. So I have a closed circle on -2, but this says that it's less than, so I'm going to the left because x is smaller than -2. Whereas this one is an open circle on 1, but it's bigger than 1, so this is going that direction. Notice that with or statements, we get these going the opposite direction, whereas and statements, they get connected in the middle. So that's our graphing. If you've got questions, again, you can leave them in the comments or ask me in class. Do something, right? But let's move on to solving. Solving with an inequality is basically the same as an equation. There is one slight difference, and I will mark that difference as we get there. So let's go ahead and solve this. Same rules. We're trying to get the x isolated. So I'm going to subtract 7x from both sides because I want to get all the x's on the same side. So this is negative 2x plus 2 is greater than negative 4. And I'm going to continue solving. Again, no changes in how I'm doing this. I'm subtracting 2 on both sides. Negative 2x is greater than negative 6. Here is where we get the change. This is the only difference. And that difference is that when we divide or multiply by a negative, we flip the inequality. So right here, this next step, we're dividing by negative 2. Because we're dividing by negative 2, I need to make sure that instead of this being a greater than sign, it's a less than sign. So right here, we flipped. We went from a greater than to a less than. So if I were to draw this, right, it would be a 3. It would be an open circle on 3 with a line off to the left. Because when you divide by a negative, you flip the inequality sign. Aside from that, solving an inequality is exactly the same as solving an equation. All right, let's do 2 more examples, and statements and or statements. So as I said before, this is an and statement because this is negative 4 is less than 6x minus 10, and 6x minus 10 is less than or equal to 14. Notice how when we have these two connecting in the middle, it becomes an and statement. Now I could write it like this, but I don't, because when they connect in the middle, we have this method to kind of shorten it. The and isn't written because it's implied in the two inequalities. So we can solve this. Again, we're trying to get the x by itself in the middle. And the methods are the same. It's just, notice that there's 3 sides, right? There's a left, a center, and a right, whereas normally there's just a left and a right. What you're going to do to solve is everything you do, you're going to do to all 3 sides. So do all operations to all 3 sides. So we're adding 10 to all 3 sides, and I get 6 is less than 6x is less than or equal to 24. And then I divide by 6, I divide by 6, and I divide by 6, doing it 3 times, and I get 1 is less than x is less than or equal to 4. Final answer. Blah, blah. And again, I can graph this. It's an and statement, and so I know that they connect in the middle. Open circle, closed circle, connection in between. Or statements, on the other hand, you do write the or. It's 2 inequalities. It's this inequality or it's this inequality. Or statements go in opposite directions. They don't contain the same numbers. So with an or statement, all you're going to do is simply solve each one. And you're solving these using the same rules that we have always solved them. This is why I'm going through this rather quickly. I'm solving both of these equations in the same way that I always have. And then when I get to the end, because it's an or statement, it just means that when I graph this, I'm putting these 2 things together. So this is 2 and 6. It's closed circle on the 2, closed circle on the 6. The x is less than, so it's this way, and the x is greater than, and it's this way. And that's our last example for this video. In the next section, in 1.7, I forgot what number this was. In 1.7, you're going to need to be able to do and or statements. In fact, you're going to need to be able to tell the difference between them when we're looking at an absolute value. So it is very important that you get down and solid on these. Okay. So thank you very much for watching. And again, if you've got any comments or questions, feel free to leave them in the comments section. And yeah, thank you for watching. We'll see you another time.